Welcome. Today we are looking at section 4.5, simplify expressions and solve equations. So I really like this section because it's pretty much just a review because we started with expressions and then we moved to equations. So now we just get to practice identifying what's the difference, okay? So what we have here to start is number one, and we're going to try to figure out, is it simplify or solve an expression? What do you think? We can simplify an expression and we can solve an equation. Okay, so for this first one here, decide whether each is an expression or an equation and then either simplify or solve. So this first one, 2x minus 7x, what do you think? It's an expression. Okay, so that means we're going to simplify. So if I have 2x's, take away 7x's, I have negative 5x's. Next one, 2x minus 7x equals 15. Is that an expression or an equation? That's an equation. Okay, all the equations have the equal sign. Okay, so it's an expression if it doesn't have the equal sign, equation if it does. So now let's go ahead and solve it. So 2x minus 7x, I already figured out, was a minus 5x equals 15. Go ahead and divide both sides to solve for that x. So I have a negative 5x over that negative 5 will cancel out, leaving me with x equals 15 over negative 5 is negative 3. All right, not too bad, right? Let me see. How about you try these two? Okay, so first figure out is it an expression or an equation, and then go ahead and simplify or solve. Okay, and for number, let me go ahead and write them so that you can pause the screen. Okay, I kind of like it when we do that. This number 3 is going to end up being negative x plus 33. And number 4 ends up being x equals 33. Okay, so pause your screen here. Go ahead and do the work. Come back when you've got it or when you're stuck. Okay? All right, so number 3, I just went through and distributed. Sorry about that little error there. I think I saw the 3 and I multiplied it by the 8. So hopefully that didn't throw you off too much. But that does end up being negative x plus 33. And then for number 4, distributed, combine like terms. X is to one side, constants to the other. got x equals 33. Turn the page. Let's go ahead and have you try the whole page. Okay, you should know how to do these, right? Because we've been practicing a lot with the decimals, fractions, whole numbers. So go ahead and try all three of those. Let me put the answers up. All right, so go ahead and hit pause right here. Go ahead and work through them and come back when you're ready. All right, I'm going to stop there for just a second. Number 5, I don't suspect there were any problems. Number 6, I'm assuming was probably okay. So it was just combine like terms, get the x's to one side, constants to the other, approximately negative 3.17. This one, it throws people off. When it's an equation, though, that's when you can go ahead and multiply every single piece by that lowest common multiple. Okay, so far what I've done is I've written out that 2, 6, 3, and 4 are at their multiples. I rewrote the equation with the space in between. Okay, so again, this only works with the equation because we have both sides that we can balance with an expression. There's nothing to balance it against, so we can't do it with an expression. So now what I'm going to go ahead and do is multiply every single term by that 12 over 1. I'm going to make this look a little bit better here. Oops, I didn't mean to do that. So I don't know if that doesn't bother you to have that minus sign in between. To me, it was just kind of looking weird. I don't want to do that. So I'm going to put the minus and then my space here. And then here I'm going to put my plus so that I can get my 12 right next to my fraction. All right, so if you didn't get this far, go ahead and stop now and see if you can finish off this problem. Okay, so again, this one ends up being 14 over 33. Okay, so go ahead and finish this one off. Come back when you're ready. All right, so we went ahead and canceled the 12 over 2 for 6, 12 over 6 for 2, 12 over 3 for 4, 12 over 4 for 3. And then multiplied it out to get that single line equation without any fractions in it. Got all the x's to one side, constants to the other. X equals 14 over 33. All right, very good. Let's keep on going. Oh, here's a fraction one now. That's not the equation, okay? So that method that we just used will not work because there's no equal sign to balance it against, right? So this is an expression. Okay, go ahead and give it a try. In this one, we're going to need to find a common denominator. But let me start us off together, okay? I don't want to send you off quite yet. Let's go ahead and put the x's right next door to each other. Okay, so do the 7 over 2x plus, go grab that 3 over 4x. Put them right next to each other. And then get those the constants. I'm going to even change colors. Let's see, minus 5, 6, minus 1/3. Okay, so we need common denominators. Do we need to have a common denominator that works for all 4 terms? We do not. Okay, it does not have to be that way because we can't combine all of them, right? We can combine our x's, which are the first 2, and our constants, which are the second 2. So really we have 2 little mini problems going on in here. Okay, so we want to figure out what is the common denominator with these 2, and then what's the common denominator with the second pair. Okay, so now I think I want to go ahead and send you off. Go try to find it. Find what those common denominators are. See if you can scale up the numerator and combine like terms. Okay, come back when you think you've got it. Okay, I just want to make sure everybody's on the right track. So if you got further than this, awesome. Okay, but just a little check-in point here is hopefully for your first 2 you got 4 and your second 2 you got 6 because that would be the lowest common denominator. For the first one, the 7 over 2, if we're scaling that up, 2 to the 4, we're doing times 2. We want to blow up that whole fraction, right? So if we blew up the bottom by doing times 2, we need to do the same to the top. So we would get 14. Okay, now over here, 3 to the 6, another times 2. Since we blew up the bottom, blow up the top, we're looking at a 2. Okay, so if you didn't get this far, go ahead and pause it again and give it a try. Come back when you're ready. If you did make it this far, let's go ahead and see how you did once you started combining. All right, and that is our final answer. So we had common denominator of 4 for the terms with the variable. So it would be 14 plus 3, we got 17. And then with the common denominator of a 6, we have a -5 minus 2, which would give us a -7. So just a -7 for that one. All right. Let's keep going. Looks like there's only one on the bottom of this page here. So this one says, translate into an expression or equation. Okay, let x be a number. And then it says the quotient of the number and 2 is equal to 3 times the difference of the number and 5. Wow, that has a lot going on, right? Hit pause and take a guess. Okay, just go ahead and try your best guess and then check in with me when you're ready. Okay, so I like to use a lot of different colors here, and I just have to break it apart. So I'm going to start here. This is equal to, I definitely know what that means. That means equals, right? Now, let's just take this one step at a time here. So the quotient, what does that mean? Quotient means divide, or it means fraction, right? The number is x. So the quotient of the number, here's our separator, and 2. So quotient of x and 2, I'm going to write it as a fraction. Okay, so x over 2 is equal to, now what do we have over here? 3 times the difference of the number and 5. So 3 times, and it's saying a bunch of stuff right here. So that's going to be what goes in parentheses. Difference would be subtraction. The number is x. Separator is and. So the difference of the number and 5 would be x minus 5. Okay, hopefully that wasn't too bad. Okay, now go ahead and take this one and solve it. Okay, so you should get x equals 6. Just to help start you off here. We have an x over 2 on the left. The way to get rid of that, since it's a fraction, is we want to multiply both sides by 2. Okay, so that's going to cancel out the 2. And then this is going to be 2 times right here. Okay, so we just did times 2 on both sides, which we can do. So now I have x equals, and then go ahead and try to figure out where we might go from here and come back when you're ready. All right, so at 2 times 3, I got 6. Distributed my 6, moved them over, divided by -5, and a -30 divided by -5 is a +6. All right, next, we have 4 minus the quotient of the number and 5. So go ahead and hit pause. Give this one a try. This one's just going to be an expression, right? Because it doesn't say is equal to. So go ahead and try this one. Come back when you're ready. You can just do the expression. Don't worry about simplifying it. Okay, so in this one we have 4 minus, so let's do 4 minus, and then we have the quotient, which is divide, of the number we know is x, and as our separator, 5. So 4 minus the quotient, which I like to write as a fraction, x over 5. Okay. For me, if you wanted to leave it like that, that would be okay. Some people like to just see it as one fraction just because it looks nice. So let's go ahead and just show you what that would look like. So I would put it as over 1. And then I would want to get common denominators here, which this is good practice anyway, and it does look nicer. So that 4, what are we going to scale up that 4 so that matches our 1 to the 5 as we did times 5, right? So that 4 times 5 would give us a 20 up top. So you'd have a 20 minus x all over 5. Okay, and that looks good. All right, and I think we're done. Yeah, this is section 5.5 next. So we will start off here tomorrow, and that wraps it up. I hope you have an awesome day. Bye.